These are the notes for AP Calculus on the topic of finding the area between two curves. So if f of x is above g of x on the interval from a to b, then the area between the curves on the interval is given by this integral, where f of x minus g of x is giving you the height, and the dx is the width of each of these infinitely thin rectangles, which we'll see. So it says sketch the region bounded by the given graphs and set up the definite interval to find the area between the curves and then find the area enclosed by the two functions. So what we can do first to see where these intersect is to set them equal to each other. So you can set x squared plus 1 equal to x plus 3. Because really what you're doing is substituting this in. They're both like y equals, so you're really substituting this in for y in the other equation. And then if you subtract over the x and the 3, you get x squared minus x, 1 minus 3 minus 2 equals 0. And then that would factor into x minus 2 and x plus 1. So you can see we get x equals 2 and x equals negative 1. So those are the x coordinates of the points where these two graphs would intersect. And then we can just sketch the rest of the graphs here. So for f of x, this is just a linear equation, x plus 3, so the y-intercept is 3 right here. The slope is just a 1. Over 1, you can see it looks this. Oops. I don't need to graph it that far. There's f of x. And then intersects at 2 and negative 1. And then g of x is a parabola. That plus 1 shifts it up 1. So g of x would be parabola starts here instead of the origin. Goes up like this. So you can see the points, you don't need a perfectly accurate graph here. You see here's the region enclosed, that's where we find the area. And where they intersect here, you found this is negative 1, x equals negative 1, and this is 2. So you can draw your representative rectangle there. And this first two example problems we're going to do without calculator. And then the last two we'll do with graphic calculator. So what we're really doing here, now you can see f of x minus g of x, that really takes the y-coordinate of this one minus the y-coordinate of this one. That's why you need the one that's above first to get the height of each rectangle. And then the dx, that's the width of each rectangle. So to find the area, we just integrate from a to b. In this case, the intersect at negative 1 is the lower limit. And they intersect at 2, that's the upper limit, as you go from low to high. So we're integrating all the rectangles from negative 1 to 2. And the one on the top that has a bigger y-coordinate in the region goes first. So that would be our parabola, our linear equation, our x plus 3. And then minus the one that's on the bottom here is our parabola, the x squared plus 1. Make sure you put a parentheses like that, so you're subtracting the whole thing. And then this whole thing is times dx. So this is one that's pretty easy to integrate by hand. So you have the integral from negative 1 to 2. When you subtract those, see we'll get x minus x squared, and that becomes 3 minus 1, so plus 2 dx. And then you can go and integrate that. Integral of x, antiderivative is x squared over 2, minus the antiderivative of x squared is x cubed over 3, plus the integral of 2 is 2x. And this is a definite integral, so it's evaluated from negative 1 to 2. So I'm going to substitute in 2. 2 squared over 2 minus 2 cubed over 3 plus 2 times 2 minus Plug in negative 1. Well, negative 1 squared over 2 minus negative 1 cubed over 3 plus 2 times negative 1. So we just have to simplify this to get our area. So that would be 4 over 2, that's just 2 minus 8/3 plus 4 minus negative 1 squared is 1, so that's 1/2. That's a negative 1 in the cubic, but that negative makes it positive, so plus 1/3 minus 2. And then what I would do is combine all the ones that have the same denominator first. So we've got 2 plus 4 is 6, plus 2 is 8. Combine the integers. Then we've got negative 8/3 and a negative 1/3, that's negative 9/3. And then minus 1/2. But negative 9/3 is the same as negative 3. So that's really 8 minus 3 is 5 minus 1/2. Which if you get a common denominator, it's 10 over 2 minus 1 over 2 gives you an area of 9 over 2. There's not specific units here. You could put units squared in its area. That would be your area, 9.5 to 4.5 units squared. Okay, let's take a look at another example without calculator. So this one you can do the same thing, but we've actually got 3 equations here instead of just 2. So another way, rather than just set them equal to each other, is to just sketch the graph. So we've got y equals the square root of x. So easy numbers to substitute in there would be 0. If you plug in 0, you get 0. If you plug in 1, square root of 1 is 1. If you plug in 4, square root of 4, you get 2. So that gives you this comp parabola that looks like this. Y equals the square root of x. And then y equals negative 1/4 x. That is just a linear equation. Plug in 0, you get 0. Well, the slope of negative 1/4, so it goes down 1 over 4. That's like this. And those 2 equations alone, you can see, don't form a region, which is why there's a third equation on this one, and that's x equals 4, which is just a vertical line right here. So then you can see now here's our region enclosed, and you can draw your representative rectangle, so in there. So, the integral we'd set up to find the area here. Well, you can see this region starts at 0, where they intersect. And this time, they don't intersect again, but what stops the region is the vertical line x equals 4. So it'd be from 0 to 4. And then we take the one that has a bigger y coordinate, which is the square root of x, minus the one with the smaller y coordinate, which is negative 1/4 x, all times ds. And then in order to integrate this, we can simplify this. Instead of square root of x, rewrite that as x to the 1/2. And negatives cancel out there, so plus 1/4 x dx. And now when we find the antiderivative, using the power law, x to the 1/2, you add 1 to the exponent, so it becomes x to the 3s. Instead of divided by 3s, that's the same as multiplying by the reciprocal, 2/3. And when you integrate this, the 1/4 just stays out in front. And then when you integrate x, you get x squared over 2. This is from 0 to 4. and simplify that a little bit. Get 2 in radical form, that'd be square root of x cubed over 3, plus this would be x squared over 8, log of 2. That is from 0 to 4. So if we substitute in the 4, the square root of 4 is 2. Cubed is 8 times 2 gives you 16 over 3. Plus 4 squared, 16 divided by 8 is 2. Minus, when you plug in 0, they both just give you 0. So if you get a common denominator here, 16 thirds plus 2 is the same as 6 thirds. Adds up, the area of this region would be 22 thirds. And again, there's no specific units. If you want to remind yourself its area, you can put units squared on the number. Now let's take a look at a couple of problems finding the area between two curves when using a graphing calculator is helpful and necessary. So this one says, sketch the region bounded by the given graphs, set up the definite interval to find the area between the curves, then find the area between the two functions. So I'm going to show you using two of the more commonly used graphing calculators, and that's the TI-84 and the TI-Nspire. You can do the same thing with other graphing calculators, but these are two of the more user-friendly ones. So let's first look at how you using the TI-84. So on this one, the first thing you want to do is make sure your mode here is right. Make sure you keep it in radians here. Normal, you can keep this on float, so all these settings should look similar to what we've got here, function form. And then on your window size, so if you hit window, you can change what part of the graph you're going to see here. So on this one, let's change our window size so it fits to look like what's like on here. So I'll make the lower limit -3. And when you put a negative out in front, you have to use the negative in parentheses right here, not the minus sign right here. So careful of that. -3. X minimum, that's the lowest x value we're going to see. And then the x maximum, that's the highest x value. So we're going to go from -3 to 3. Just use your arrows here. X scale, you can usually keep that at 1 if you just want it to go by ones. And then Y minimum, -3. Y maximum, 3. Again, a Y scale, you can keep it at 1 along with the resolution there. And then after you do that, let's go to Y equals. This is how you enter in functions. So you hit Y equals. And then we'll type in X. When you type in any variable, you can use this X, T, theta, N button. And then squared, you can do one of two ways. You can either hit the squared button here, or for other exponents, you can hit the exponent button right there, and then 2. So either way. Just going to use the squared, and then here's where you use the minus, when you're actually subtracting things, when the negative is not out in front. So 1. Notice it highlighted the equal sign automatically when you typed it in, which means it's going to be graphed. You can always go back and keep in your calculator and hit enter on the equal sign and de-highlight it, and it'll keep it in the calculator, but now it won't graph it anymore. So just hit enter to keep that active now. Now go down to Y2, and we'll enter in 3, and here's sign right here, and then X, and then close parentheses. And then you can hit graph, and what it's going to do before I press this button, it's going to graph these both on the same axes, since they're both highlighted here, and it's going to graph in the order we typed them in. So the first graph we're going to see is the x squared minus 1 graph, and then we're going to see the 3 sine x graph. So there's our parabola, x squared minus 1, and then there's the 3 sine of x graph. So the graphing calculator graphed it, but it's still useful to sketch the graph on paper. So I'm still going to graph these on paper, even though the graphing calculator did graph it. So this will be a rough sketch of what that looks like here. So the parabola, like that, that's f of x. And 3 sine of x graph. Really, we don't need to see the whole thing. We just need to see the region that was enclosed there. something like that. So there's our region enclosed. And we can draw a representative rectangle in there. Dx. And one reason why we need the graphing calculator in this problem is because if you try to set these equal to each other, it's not one you can solve easily by hand. So the graphing calculator is going to help us to find these points of intersection, which I'm just going to call x-coordinates A and B. So we'll find those in just a second. We'll see how to do that. But let's go ahead and set up our integral here, and we'll see how the calculator can help us to do that. So the integral would be from A to B. The one on top of this region is actually g of x, so that one would go first because it has the bigger y coordinate. Minus the one on the bottom is f of x, that has a smaller y coordinate in this region. All times dx. But we need to figure out what a and b are. So let's see how we do that with the TI-84, and then I'll show you how to do that with the Spire. So let's go back to our TI-84 calculator here. And to find points of intersection, once you have it there, you go second, and then calc for calculate, or you can think about it for calculus. And then you go down to number 5, or hit number 5 and intersect. And it asks you for the first curve, so you can see y1 up in the upper left-hand corner. It's just asking you which curves are you trying to figure out the intersect, in case you have more than 2 in your calculator. Today we just have 2, so it's easier. So there's y1, you just hit enter, first curve, enter. Second curve, it automatically goes to the next one, y2, enter. So we want to know where those two graphs intersect. And then your guess, you just use the left and right arrows, or you can type it in manually, the x value, and put it close to the point of intersection you're looking for, and then hit enter again. And then you can see it gives you what a equals, negative 3.067554. So what you want to do is write it down on paper, because we need to know what that a is when you set up the integral here, as well as stored in your calculator, which I will show you how to do. So let's write it down, what a is. So a equals negative 3.0675. And then the easiest way on the 84 to store it in your calculator is to just quit out of here, second quit, the mode button, and then hit the store button, STO with the arrow, and then alpha, and then choose the letter. You want to see all these letters. On mine it's in green, on your calculator it may be in a different color. All these letters are basically allow you to store different constants in your calculator that you may need to use again. So I'll put A. And then hit enter. And then there it is. If that doesn't work on yours, some of the calculators that are similar to the 84, you actually have to type it in and then hit store, and then alpha, A, or whatever variable you want to store it as. And it shows you, confirms that's the variable. That's what it's stored as. And then let's do this for the other point of intersection. So go back second calc, again, intersect, number 5. First curve, y1, enter. Second curve, y2, enter. This time your guess is going to be up here. So instead of using arrows, let's say it looks like it's about at 2. You can actually just type in 2 and hit enter. That can save you from having to wear out the left and right arrows on your calculator. So our b value turns out to be 1.9468777. And then what you do is second quit. Well, let's write it down on the paper first. I'll just store it here first. I'm going to write down store alpha b. Now it's in our calculator as b. So let's write it down on paper now. So d equals 1.9468777. The reason why you have to again write it down on paper is if you don't, if somebody looks at this info, there's no way they're going to know what you have in your calculator as A. You have to write down what they are. But it's useful to have them in your calculator as A because now we don't have to type those numbers in at all. That's not a type of knowledge. The final thing is to figure out how to not this integral. So I'll show you on the 84, and then I'll show you how to do all those same things on the Inspire. So on the 84, to integrate, hit the math button and go down here to number 9. That stands for function integrate. And then you want to type in what you want to integrate, which in this case is g of x minus f of x. So g of x was the y2. So the way you access those is you hit the vars button, stands for variables, and hit the right arrow, y variables, function, and go to y2. And then minus, and then we want f of x next in our integral. So that would be y1. So again, hit the vars button for variables, y variables, y1. And then after you put what you want to integrate, you put a comma, and you put the variable, which is x. Then you put a comma, then you put your lower limit, which we stored as alpha a. If we didn't store it, we'd actually have to type it in. Then comma, alpha b, and then a close parentheses. And enter. And it gives you the answer for that definite goal. So our area of our region is 3.746. Now on the AP test, you just need to be accurate to 3 decimal places. So you can either truncate it, just cut it off after 3 decimal places, or round it if it rounds up to 3 decimal places. You can put more than that if you want to, but that's all that's necessary. So this integral equals 3.746. So make sure you set up the integral correctly. It's an important part of it. And now let me show you how to do the exact same things on using the TI Inspire calculator. So if we go to our Inspire, first thing on the, let's make sure our settings are okay. So if we go back to the main menu here, you can use your arrows there, go down to settings, enter, and then choose document settings. Oops. Try that again. There we go. And display digits, that's kind of up to you what you want to do. I'm going to put it on, because I want to make sure it's accurate enough, so I'm going to put mine on fix 6. So it'll always show me 6 decimal places, which will be plenty accurate enough. And angle measure, you want to keep it in radians, or put it in radians if it's not already, instead of degrees. Exponential format, normal, real numbers. Calculation mode, this one, sometimes it'll give you exact answers. So what you probably want to do to keep it as decimals always is to put approximate on that. Vector format, rectangular, and the base decimal. And then just click on make default. So that way all the new documents you create will have those settings. Okay. And then new document, go up here, enter. Okay, and then what you want to do in the document is add a couple things. Add the graphs, and then document, and you also want to insert the calculator. So you want to have a graph and a calculator. So if you go back to the graphs here, notice sometimes it's on the top, some on the bottom, depending on your Inspire. So you would just type in your equations there. So the first one was x squared. So here the x is right down here. Here's squared. Or again, you can use the exponent button right here if you want. And then minus 1. And hit enter. And it already graphs it there for you. And then if you hit a tab, that will take you to the next one, f2 of x, it calls it instead of y1 and y2. And this was 3 times sine. Here the trig functions are right here. Sine of x. And hit enter. Okay. Again, here to change your window size on this one, you can see the region there, but if you want to change the window size, you can go to menu, analyze graph, window zoom I mean, and then window settings, and you can do the same thing here. Again, if you want the negative out in front, use the negative in parentheses right here, so negative 3 to 3. You can scale automatic, or you can make it, usually it's easiest to keep it automatic, and y minimum, let's make that negative 3 to 3. So it's the same there. And then to find the points of intersection on Inspire, you just go
menu, analyze graph, number 4, intersection. It asks you for a lower bound. Choose something to the left of the point of intersection, like over here. And an upper bound, choose something to the right of the point of intersection right there. And then it gives you a point of intersection there. There's your x-coordinate. Now it's actually more accurate than this, but it's only showing you 3 decimal places. So you just click on that and hit the variable button, variable, and store, and then you can type A and enter. Now it puts it in bold, say it says linked equals A, so we know that's stored as A. And then to find the other point of intersection, do the same thing, menu, analyze graph, intersection, lower limit, choose lower bound, choose something to the left of the point of intersection, upper bound, choose something to the right, and there's your point of intersection here. Again, even though it's only showing you 2, it's actually stored more accurately. Variable, store variable, and then hit B. And that's bolded as B. And then to integrate it, you would just go over to this menu here, to the calculator. Just go over to your calculator, or click on that, and then you would just define your integral. You hit this button right here, and you can see the definite integral is right there. Lower limit was A. Just hit tab. Upper limit B. Tab, and then what we want to integrate was F2. So that's what you get your variables. Hit the variable. There's F2 of x. Oops. The cursor right there. So then minus. Notice it already adds parentheses there for you nicely. F1 of x. And then dx. And you can see they get the same answer, 3.746. Okay, let's look at one more example problem with the calculator. Again, I'll show you on both calculators how to do that. So here's our equations here. So let's go ahead and enter those in. And I'll show you on the 84 first. So y equals. And you can just clear these out or override them here. Clear button. And then we've got 3x squared. And then here divided by, we should put parentheses because we want to divide by this whole thing. X squared plus 2x plus 5, close parentheses. Then go down to y2 is a natural log right here of x plus 3. Sorry, x plus 5. Close parentheses. And let's change our window size. Let's make it -5 to 5 this time. So you can just override it there. And y minimum, let's make that -1 to 5. And graph. So there's the first equation graphed, and there's the second one. Okay. So notice those two don't form a region, just the two of those. However, we've also got x equals 3. So this is not a function, so we don't have to enter in our calculator, we just have to draw it on the graph itself. So let's go ahead and do a sketch of what these look like here. The first one looks something like this. And the second one, natural log graph, shifted left. Normally it goes through 1, 0, shifted to the left, 5 units. Something like that. But we also have x equals 3. So the calculator doesn't graph that, and we don't need it to. Just graph the vertical line right there. There's x equals 3. And now, let's set up our integral here.
There's our region enclosed. Next. So this time we have to find just one point of intersection, which I'll call A. So the integral here would be from A, and we don't have to find another one because the region stops right there with a line x equals 3, so from A to 3. And then the one on top this time is this one, the natural log of x plus 5, so that would go first. It's not labeled a function this time. Minus, the one I'll do a second is the 3x squared over x squared plus 2x plus 1. The whole thing. Yes, that would be the integral that gives us our area of the region. All we need to do is find that point of intersection. So let's go ahead and do that. On the 84 first. So you would again just go second, calc, trace button, and then number 5, intersect. First curve, y1. Second curve, y2. Guess, move the cursor over here or type in the guess, and hit enter. So this time, A equals negative 1.334,322. And again, to store it in your calculator, you just go second, quit, store alpha A. And then to get it to integrate what we want for us, you would just go math, function integrate. See, it's the second one first, so it'd be y2, so variables, y variables, function, y2, minus variables, the right arrow y variables, number 1 function, y1. And then comma, the variable in terms of is x, comma, the lower limit is a. And when we put this in for a, the value we previously stored for a is gone. It got overridden by this one. So you can only store one constant per letter at a time. And then comma, the upper limit is 3. Close parentheses. And you can see we get 5.009. And here's, since it's a 6, you can either make it 5.009 or round it up 5.010. So let's go ahead and write that down along with our constant. So A on this one was negative 1.334,322. And this integral worked out to be 5.009 if you truncate it, or 5.010 if you round it, or you can just write the whole thing and not round it all, it's fine. So there's the integral set up correctly, and that's what it is. And let me just show you how to do the same thing using the Inspire again. So using the Inspire, if you want to keep those in there, you can just save as a document. I'm just going to make a new document, going back here. I'm not going to save this one. So again, I'm going to add the graphs and insert calculator as well. And on the graph before, remember the points of intersection, I kind of rounded off too soon, so let me change the settings here. Oops. Document settings. And I think I need to change the, those are all fine, the graph settings here. Let's go settings on here. There's the graph settings. So mine now is on float 3. So for the graph settings, so we can see more accurate, let's make it fixed 6. So we always see 6 decimal places. Keep it in radians. And that should be fine. Let's make that default.
So now when I find the points of intersection, it'll show it to me a little more accurately. And let's enter in our equations. Which were 3x squared. Now this one you can actually put as a fraction like this, a little easier. And then x squared plus 2x plus 5. Okay. Sure. And then hit tab there to enter another one. Another one is natural log, which is right here. So you have to hit control and E the X button of x plus 5. And again, if you want to change the window size again, you go menu, window zoom, window settings. Let's make it from, you know, negative out in front, you get this negative, so negative 5 to 5, y minimum, negative 1 to 5. So oftentimes you just have to play around with the window size to get it to fit where the region is. There we go. So there's only one point of intersection, so let's go ahead and find it here. So you go menu, analyze graph, intersection, lower bound right there, upper bound right there. Now notice since we changed the settings, now it gives us the point of intersection more accurately. So then you would highlight that and then variables store, and then hit A, enter. And then just go over to the calculator part and then set up the integral. So the integral from A tab to 3 is the upper limit. And y2 is first, so it's f2 in this case. X minus, and it adds the parentheses already there for you, f1 of x dx. And you can see you get the same answer using inspect. And that concludes the notes for AP Calculus on the topic of finding the area between two curves.